welcome to Pythagoras Theorem in 3D. Just before we start, a reminder that there is a notes jotter available for this video. Just check the description below for a download link and you can work along with me as we go through the video. So in our first example here, we've been given a cuboid A, B, C, D, E, F, G, H, and we've been given the lengths of AB and AD and DE, but we've been asked to find the length of DG. Now, unfortunately, DG is a line joining together two diagonal opposites. And in order to find this value, we actually need to start thinking about right-angled triangles. The whole point of this question is it's within a cuboid. We have right-angled triangles in lots of different positions. But in order to make the right-angled triangle that actually includes GD, we need another value as well. We need HD, because what we want to do is find the right-angled triangle here. We know this is a right-angled triangle because GH is at a right angle to the base of the shape, and so the eventual triangle that we're trying to find is using a quick sketch. Well, I want to know from H to D, from G to H, from G to D. This length here, G to D, or DG, is the value we're actually looking for, but at the moment I know very little about this. The only thing I do know is that GH is the same as the height, and so that one would be 6 centimetres. But the question is, what is HD? Well, HD, that is going to come from the right angle triangle which is formed at the bottom. So the first thing I'm actually going to do is create another right angle triangle, a quick sketch, just so I can work with it. I know that the triangle that I'm looking for is AHD, and I know that this length is 9, and I know that AH is 3. So I need to find the length of HD. Now HD is the third side in a right angled triangle. If you know two sides, you need to use Pythagoras' theorem. So we need to use a squared plus b squared equals c squared in order to find our answer. And so in this case, a is going to be 3, b is going to be 9, and that's going to equal c squared. 3 squared is 9, 9 squared is 81, and that gives me c squared. So finally, that tells me that c squared is 90 if I add those two together. So I need to find the square root of that. In that case, I'm going to need a calculator. So the square root of 90, well, it comes up as 3 root 10. That's not going to help us right now. What is a decimal? So 9.487 would be the answer I'd be given there. 9.487 is C. And so this length here, 487, is HD. So I can add that to the diagram that I've drawn at the bottom, 9.487. So lastly, I wanted to find GD. Now again, in this case, this is a right angle triangle, and I want to find the third side. So I'm going to use Pythagoras all over again. I'm going to use a squared plus b squared equals c squared, and I'm going to put in the values that I have gotten. So a is 6, so 6 squared, and plus b, and that is the 9.487, that's been squared to give me c squared. Now this time, when I grab my calculator, I'm actually going to use the answer button just to make sure that this value, which is actually a little bit longer, is still in use. So what I'm going to do is 6 squared plus ants squared. That means I'm definitely going to use the full version of the 9.487 in my working out, and that comes to exactly 126. So c squared equals 126, and so if I want to get c, well, that's going to be the square root of 126, and that comes out at 11.22. Okay, so in our next question, we're asked to find the length of CE. Now, again, all I want to do here is I just want to add on some little lines to the diagram, just so I can keep track as to what I am actually looking for. So eventually, I need CE. Now, in order to find CE, I'm going to need the rest of the right-angled triangle that is involved with it. And so, I might look here and see my right-angled triangle at CBE. And so that will mean I need to know the value of this line. And so if I need that length, then I'm also going to need the right angle here. I'm going to go to the triangle which has C at the top and B at the bottom. It has a height of 4. But the key here is that the 6 centimeters across the bottom, that's actually the total length across the bottom of that diagram. And so we need to realise that this is a halfway point where we've dropped the perpendicular line for the height. That is halfway along AB, and so the bottom is actually only 3 centimeters. But I want to work out what CB is, so I want to find out the hypotenuse of this triangle. And so again, I'm going to use a little bit of Pythagoras. A squared plus b squared equals c squared. So in this case, I've got 4 squared plus 3 squared equals c squared. 4 squared is 16, 3 squared is 9, and so 16 plus 9 is c squared. That is 25, so 25 is c squared, and so the square root of 25, well, that's one where I don't need a calculator. The square root of 25 is 5, and therefore CB is 5 centimeters. So then we need to think about the triangle I've drawn in green. So that triangle, we now know that the base of that triangle was 9 centimeters, and we also know that the height of that one was actually 5, because that is CB. And so again, I'm trying to use a bit of Pythagoras in order to find the remaining length. So I've got a squared plus b squared equals c squared. A is 5, b is 9 equals c squared. So that's 25 plus 81 is c squared. And so that is 106. And so if I want to get c, I need to do the square root of 106. So I'll bring up my calculator and I will take the square root of 106, and it tells me it's root 106. I'll change that into a decimal. 10.30 if I went to 2 decimal places there. So 10.30 is C. And that is the length I was looking for, C to E. And so that is my final answer to 2 decimal places. Next, we're going to look at calculating the perpendicular height of the square-based pyramid. Now, it's very important when we deal with pyramids that we understand where the height is actually measured from. The height is measured from the very top vertex of the pyramid straight down to the very centre of the square base. And so that is the perpendicular we're looking for. We're trying to get to the very centre of the square base. And so if I want to do that, I need to start again thinking about right angled triangles. Where is there a right angled triangle involving the line going from E to the very centre of the triangle? Well, the answer is here. The right angle, as it says, it's a perpendicular height, so that line is at a right angle to the base of the shape. And so what we need is eventually to use the 7 centimeters, which is on the slope of the pyramid, and going up from the centre, which we'll call M at this point, just centre of the square base. But we need more information. This is the one EM that we're actually trying to find, but MC we would need to know first. And how can we find MC? Well, MC is part of another right-angled triangle. This is a square-based pyramid. And so, if we think about this bottom piece, then this must be a right angle, 4 centimetres and 4 centimetres. And so, if we use our Pythagoras theorem, we've got a squared plus b squared equals c squared, which means we have 4 squared plus 4 squared equals c squared. 4 squared is 16, so 16 plus 16 is 32, so c squared is 32, and therefore we need to find the square root of 32. So again, we'll grab our calculator, square root of 32, and it comes out at 5.657. 5.657. Now, that is the length all the way across here, going from A to C. But M is the midpoint of the square base, and therefore it is only actually half of that length. So the next thing is, if I want to get the length here, M to C, I need to half that value. So I'm just going to go back to my calculator and I'm going to divide by 2, and that is 2.828. 2.828. And this time I'm trying to find EM. So now I've got enough information on the diagram in order to do that, but in this case I've got to just be careful when I do a squared plus b squared equals c squared, because this time I already know b. I know that that is 2.828, but I also know c because I know the hypotenuse is 7, and therefore it's actually a squared that I'm trying to calculate, and therefore I'm going to have to do a subtraction. I'm going to have to do 7 squared take away 2.828 squared, and so I'm going to go back to my calculator and I'm going to make sure yet again that I get exactly the right answer by using 7 squared take away ants squared, because I've got the result from previously still in the calculator, and press equals, and I get 41. And so a squared equals 41, and so let's find the height of this pyramid. Well, I need the square root of 41. Square root answer equals 6.40. And again to 2 decimal places. And finally we come to the exam question, and this one came from the Excel sample paper, higher paper 3, so it is a calculator question. And again we've been given a cuboid, in which case we've been told that AB equals 7, AF equals 5 and FC equals 15. Calculate the volume of the cuboid, give your answer correct to 3 significant figures. Now you'll notice here that this question does not say anything about finding a length, but what we are looking for is finding a volume. So the first thing I want to do here is just mark on the information that I already know. I've been told that AB is 7, and so this length here is 7. AF is 5 and FC is 15. I'm going to leave that piece of information off because the first thing I want to go to is volume. Volume requires height and width and depth, and therefore the really important value is BC. Eventually I want to know how long BC is, and so how can I come up with that response? Well, let's think about the values that I do already know. I know this height and I know FC. I know FC is 15. Now I can create a right angle triangle using those values. So let's have a think about that first. So AFC, I know that FC is 15 and I know that AF is 5, and so I can calculate AC. I can use Pythagoras. a squared plus b squared equals c squared. And so a squared will be 5. 5 squared plus something squared makes 15 squared. Remember, c is always the hypotenuse in this case. And so b squared is going to be 15 squared take away 5 squared. And 15 squared is 225. 5 squared is 25. So b squared is 200. And so b equals the square root of 200. And actually, I'm just going to leave it as that for this moment, because I can use square root of 200 in my calculator when I come onto it. Because what I need to find is BC. So I need to think about a blue right angle triangle. There is a right angle right here at B. And so if I now draw in that triangle, I've got A, B, C. And AB is 7. AC is what we've just worked out. We've just worked out AC as being root 200. And so finally I want to find out what BC is. So again, a little bit of Pythagoras' theorem. A squared plus b squared equals c squared. Well, A is 7, so 7 squared. And again, it's one of the shorter sides we're actually trying to find this time. 7 squared plus b squared equals root 200 squared. Now what is root 200 squared? Well, that is quite easy, because root 200 times root 200 is 200. So 7 squared plus b squared equals 200. And so b squared is 200 take away 7 squared. Well, 7 squared is 49, so that's 151. And so b is the square root of 151. And again, I'm going to leave it as that for the time being, because it actually makes it a little bit easier to type it all into my calculator, because we aren't finished. The question asked for the volume of the cuboid, and so the volume is going to come from 5 times 7 times this length, which we've just worked out was root 151. And so to find the volume, I need to multiply those three numbers together. 5 times 7 times root 151. Grab the calculator. 5 times 7 times root 151 is 35 root 151, which comes to 430.087. And the question, let's just check 3 significant figures. Well, 3 significant figures would actually be rounding it here anyway. And so our answer is 430 centimetres cubed.